Light refraction. So already we discussed a few points. So until refractive index I discussed. Now I'll go to the next one. Next one I will explain. So refractive index. So once again we'll discuss. So when the light is passing from one medium to another medium, bending of the light takes place at the interference of the two media. That is called refraction of light. The bending of the light at the interference of the two media is refraction of light. Okay. So now I am considering, here you can observe, the bending of the light at the interference of the two media is called refraction of light. Refraction of light. Okay, so here you can see, so n equal to c by v. N equal to c by v, that is absolute refractive index. N equal to c by v, that is absolute refractive index. So the ratio of speed of light in vacuum by speed of light in medium is called absolute refractive. This absolute refractive index here I have written absolute refractive index, and relative refractive index means when the light ray is moving from one medium to another medium. So I am considering like this, one medium to another medium. So I will explain in detail, just focus on it. So now I am considering here. So here if you are taking, these are one medium and second medium. So I am taking this rare medium and denser medium. If the light ray is passing from one medium to another medium, so this is the normal line. So I am considering this is a normal line. I am taking this refracted ray. Refracted ray. So this is the incident ray. Incident ray. Incident ray. Incident ray. This one is the refracted ray. Refracted ray I am taking. So this is a refracted ray. Refracted ray. So if the light ray is passing from rarer to denser, so if the light ray is passing from rarer to denser, so at the interference of the two media, the light ray will bend. At the interference of the two media, the light ray will bend. So that is called refraction of light. That is called a refraction of light. So if it is passing from rarer to denser, it bends towards the normal line. So if it is passing from denser to rarer, it moves away from the normal, rarer medium, denser medium. It is moving from denser to rarer. Denser to rarer, it moves away from the normal line. So here, this is the angle of incidence and angle of refraction. Angle of incident and angle of refraction. Here is angle of incident and angle of refraction. So here is angle of incidence. Angle of incidence. Sorry. Angle of incidence. Angle of incidence. Angle of incident and angle of refraction. Angle of refraction. So here you have to understand one thing. In this case, angle of incident is greater than the angle of refraction. So why angle of incident is greater than the angle of refraction? Why? If the light ray is passing from rarer to denser, if the light ray is passing from rarer to denser, so at the point of interference, so it will bend, I said no. So when it is passing from rarer to denser, speed decreases. That's why it is bending towards the normal line. So this angle is greater than, angle of incident is greater than the angle of refraction, because the light ray is bending towards the normal line. Then angle decreases. Here, if the light ray is passing from denser to rarer, so this angle of incident and angle of refraction. Angle of incident is here. Angle of refraction is greater, because speed is increasing. When it is increasing, it moves away from the normal line. It moves away from the normal line. So this is about refraction of light. And coming to the refractive index, so refractive index of medium 2 with respect to medium 1. Refractive index of medium 2 with respect to medium 1. So light is moving from rarer to denser. Refractive index of medium 2 with respect to medium 1, if you are considering n2 by n1. N2 by n1, that is nothing but, so V1 by V2. As So n equal to c by v. So the ratio of speed of light in vacuum by speed of light in medium. The ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. Whereas relative refractive index, if you see n2 1. So n2 by n1, v1 by v2. V1 by E2. This is relative refractive index. Relative refractive index. So I'm talking about this one. So this absolute refractive index and relative refractive index. So problems, coming to the problems, based on this one they will ask. So here sometimes find the refractive index. Find the refractive index. Okay. So some problems I will discuss some problems. So what are the problems they given related to refractive index? Actually, few more questions are there, few more topics are there. We'll see. Light enters from aid to into glass having refractive index. So, if it is passing aid to glass, refractive index is refractive index. N is 1.5. N is 1.5. N is 1.5. And speed of light in glass is speed of light in vacuum. So, they given speed of light in air given or vacuum. Now we have to find out speed of light in glass. So now you can see. So now you can see. So n equal to c by v. N equal to c by v. So n equal to c by v given. N equal to c by v. So here speed of light is given. So c is given. C equal to 3 into 10 power 8 meter per second. And n is given. Refractive index is n. That is nothing but 1.5. So 1.5. So we have to find out v value. That is nothing but speed of light in glass. We have to find out v value. So find out v value. So we can use this formula. So if you are using this formula, so how can we write? Now see, so I'm taking, so n equal to c by v. So n equal to 1.5, n equal to 1.5, c equal to 3 into 10 power 8, 10 power 8. So c equal to 3 into 10 power 8 meter per second. So 10 power 8 meter per second, and v we have to find out. So cross multiply v equal to 3 into 10 power 8 by 1.5. 1.5. So now we can multiply with the 10 by 10. So we am considering 3 into 10 power 3 into 10 power 8 3 into 10 power 8 by 1.5. So I'm considering 3 by 1.5 into 10 by 10, 10 by 10 into 10 power 8, 10 power 8. So here 30 by 15, 30 by 15 into 10 power 8, 10 power 8, that is nothing but, so 15 2 ja, then 2 into 10 power 8 meter per second. So that is the speed of light in glass I'm considering. So that is the value, that is the answer. Is it clear? Do you have any doubts? No doubts. Okay, so this is about one example related to refractive index, and we can go to the one more concept, that is about a glass slab. So I'll explain the glass slab. Now you can see. Now I'll explain about the glass slab. So if it is taking this a glass slab, glass slab. So this incident ray. So this is a normal line, and this is the refracted ray. Still we can draw. Okay, air, glass. So here I am considering this is the air. This is the air and this is a glass slab. Incident ray, refracted ray, emergent ray. Incident ray, refracted ray, emergent ray. So the light is passing from air to glass, it bends towards the normal line. If it is passing from glass to air, again it moves away from the normal line. Away from the normal line. So I'm considering this air again. Air. So if you are extending this light rays, okay, like this. Angle of incidence, right? Angle of incident, angle of refraction, angle of incident, angle of refraction, and this is called angle of emergence, angle of emergence, angle of emergence. Okay, so now you can say the light ray is moving from rarer to denser. So I am taking this rarer, and here I am considering the denser medium. If the light ray is passing from rarer to denser, light ray is passing from rarer to denser, so it bends towards the normal line. If it is passing from denser to rarer, it moves away from the normal line. Here the speed of light is decreasing because if the light ray is passing from rarer to denser, speed is decreasing. If it is light ray is passing from denser to rarer, speed is increasing. Speed is increasing. Okay, speed is increasing. Now, so we can take this distance. This distance is called the distance between emergent ray and extended incident ray. So this is called vertical lateral shift. This is called lateral shift. Lateral shift. Lateral shift. Lateral shift. Lateral shift, the distance between emergent ray and extended incident ray is called a lateral shift. Okay, so here the this the angle of incident, angle of refraction, angle of emergency, and here one more point. So we can take the beaker. So I'm taking the beaker. So this is a coin kept at the bottom. So I'm standing here. I'm standing here. I'm standing here. So the person can able to see the coin here. Coin here. If you are pouring water, after pouring water, so the coin position will rises up. The coin position will rises up. The coin position appears here. So this is the actual position of the coin. So this is the actual position of the coin. So that is the apparent position of the coin. So this is the actual position of the coin. This is the apparent position of the coin. Actual position of the coin and apparent position of the coin. So the distance between actual position to apparent position is called the distance between actual position to apparent position is called the distance between actual position to apparent position is called vertical shift. Vertical shift. Vertical shift. So the distance between actual position to apparent position of the object is called vertical shift. The distance between actual position to apparent position of the object is called vertical shift. Okay. So here I am considering. So this distance is called vertical shift. So the distance between emergent ray to extended incident ray is called lateral shift. Lateral shift. Angle of incident, angle of refraction, angle of emergency. So this is about glass slab. So this question will come for 3 marks. This question will come for 3 marks. And one more thing. So not only this one, if you are placing the pencil. So if you are taking the pencil here. Okay. So if you are taking the pencil here. So pencil overhit. Pencil. So at this water, at the surface of water, water and air. So at this interference, the pencil appears to be bent. The pencil appears to be bent. So because of refraction, here also because of refraction only. So when you are viewing through that, we can able to see. And next one, we can take the lemon placed in the beaker. Lemon placed in the beaker. If you are taking the water inside of the beaker, if you are taking the water inside of the beaker, if you are placing the lemon inside of it, normally it appears smaller. So normally it is smaller. So when you place inside of the water, it appears bigger. It appears bigger size. It appears bigger size. So this is about 3 points. So one is glass slab, another one is a coin place, another one is pencil. So third one is, so the examples one. So this is the first one, and considering the second one. So second one, and third one. Three points I'm considering. This is about a coin and a pencil. Next one is about lemon. Next one is about lemon. So these three are very, very important. 3 marks question, they may come for exam. 3 marks question. And here we can see lateral shift. So here we have to talk about lateral shift. Lateral shift depends on lateral shift. So depending factors. What are the depending factors of lateral displacement? Lateral displacement depends on, so refractive index of the glass slab, so wavelength of the light, okay, so angle of incidence, once again. So angle of incidence, refractive index of the glass slab, angle of incident, and refractive index of the glass slab, and we can take wavelength of the light, 3 points I'm saying. So these 3 points I will explain once again. So I hope it is clear to you. Then I'm erasing. Now we can go for one more. I'm considering now. So refractive index, lateral shift depends on, lateral shift. Lateral shift depends on here. So first point is about refractive index of the glass slab, wavelength of light, third one, angle of incidence, so these are the defining factors. So based on this one, the refractive lateral displacement depends. Lateral displacement depends on the refractive index of the glass slab. So their refractive index and wavelength of incident light ray, what are the light ray we are considering, and the angle of incidence. So how much angle it is incidenting. Next one. So we'll go to the next one. So now I only refraction about refraction and refractive index I explained now. So now I am considering. So here you can see like this. So this is the point. This is the rarer medium and denser medium. This is the rarer medium. This is the rarer medium, denser medium. Light ray is coming from one point. So here, if the light ray is passing from denser to rarer, generally it moves away from the normal line. Normally, if the light ray passing from denser to rarer, it moves away from the normal line. So if you are considering one more, if the light ray is passing, so like this, at certain angle, the refracted ray gauges along the surface. Like I am considering here, like this. So here this is the angle of incidence. So here I am also angle of incidence. and the angle of refraction. Angle of refraction. So this is the angle of refraction, that is 90 degrees. Angle of refraction is 90 degrees. So here you have to understand one thing. At the at a certain angle, the refracted ray makes 90 degrees with the normal line. At certain angle, the refracted ray makes 90 degrees with the normal line. So that angle is called critical angle. The angle at which the refracted ray makes 90 degrees with the normal line, or the refracted ray passes or gauges along the surface. Refracted ray gauges along the surface, so that is called gauges along the surface, passes along the surface, gauges along the surface, that is called critical angle. So now one more I am taking. So if the same light ray is coming from the same point, so now you can see, if the light ray is coming from same source, if you are taking from denser to rarer, so like this I am taking denser to rarer, at this point. So here it makes more than critical angle. So here is 90 degrees and here is theta. So it makes more than critical angle. Then it reflect back into the same medium. So here it is called critical angle. This angle is called critical angle. The angle at which the refracted ray passes along the surface is called the angle at which the refracted ray passes along the surface. The angle at which the refracted ray passes along the surface or makes 90 degrees with the normal line. So this angle is called this angle. So the angle at which the refracted ray makes 90 degrees with the normal, that is called a critical angle. So here, if it makes more than 90 degrees, then the light ray reflect back into the same medium. Reflect back into the same medium. So this reflection is called total internal reflection. Total light internally reflection takes place. That is called total internal reflection. Now I am going to the next one. Next point is spherical lenses. So spherical lenses I am explaining. Spherical lenses. Spherical lenses, there are two types of lenses are there. One is convex lens, that is also known as converging lens. Convex lens or converging lens. Second one is concave lens or diverging lens. So here convex lens or converging lens. So why we are talking convex lens or converging lens and concave lens or diverging lens. So here you can see the first point is, so it is about I am taking the lens like this. So this is the optic center F1. So 2F1. Okay, so it is the part of the sphere. So this is the F2 and 2F2. So here I am considering this a part of this sphere. It is a part of this sphere. This also part of this sphere. So that's why this side is F1, 2F1, F2, 2F2. So whenever the light rays falls on it, whenever the light rays are incidenting on it, so like this. So those light rays will converge and meet at focus. So I am considering here. So this is F1 and 2F1. So F1 and 2F1, light rays will converge and meet at focus like this. Okay. So like this sum. So after refraction, light rays will meet at one point. After refraction, light rays will meet at one point. So that's why it is called converging lens. That's why it is called converging lens. Converging lens. Okay, so converging lens. Whereas the diverging lens, if you are taking diverging lens, this is about a diverging lens. Same, it will be like this. Okay, so I'm considering the optic center. So F1, F1 to F1, F2, F2 to F2, F2 to F2. So here F2 to F2. So I'm considering here, however, it is a circle for this. So I'm considering like this. So here also for this also circle will be there, and here also. So it is a sphere. So this is the part of the sphere. This is also part of the sphere. So F1 to F1, F2 to F2, F1 to F1, F2 to F2. So if the light rays are falling on it, if the light rays are incidenting on it, what happens? Those light rays will diverge. So those light rays will diverge from the lens, or it moves away from the principal axis. So here I'm considering, so after refraction those light rays will diverge. So here also those light rays will diverge like this. So like this. So what happens here, we can see this is a convex lens, convex lens, convex lens, and here is the concave lens, concave lens, concave lens. Here is a convex lens and concave lens. So here you can see whenever the light rays are falls on it, it will converge the light rays and meet at focus F2. So here you can see whenever the light rays are falling on it, diverging. So light rays are diverging, or light rays are moving away from the principal axis. So by the base of principal axis, by the reference of principal axis, we can say whether the light rays are converging or diverging. So in convex lens, light rays are converging. In concave lens, light rays are diverging. Light rays are diverging. That's why, so convex lens is called converging lens. Concave lens is called diverging lens. Convex lens is called converging lens. Concave lens is called diverging lens. So this is about spherical lenses. So next we will discuss about ray rules. So I'll explain about ray rules. Ray rules of convex lens. Ray rules. So now I am considering convex lens. Convex lens. So I am taking here, it's a convex lens. So optic center F1 to F1, F2 to F2. So one light I am taking like this. So after refraction it passes through focus. So first one, and coming to the second one. So if it is light rays, so optic center F1 to F1, F1 to F1. Okay. So F1 to F1. Here is F2 to F2. So one another light I am taking like this. So after refraction it passes like this. And the third one you can see, third one. So I'm taking like this. Optic center F1 to F1, F2 to F2. So if the light ray is passing like this, So it moves with without deviation. So it moves without deviation. Once again, light ray is coming from infinity after refraction passes through the focus. So light ray is passing through focus after refraction moves towards infinity. Light ray is passing through optic center. So no deviation takes place. So it moves like that. Next one, concave lens. So here is concave lens. Concave lens. Convex lens. Here is concave lens. First one, I'm taking like this. Optic center F1, 2F1, F2, 2F2. So 2F1, F1, F2, 2F2. So one light ray I'm taking it become parallel to the principal axis. After refraction it passes like this. And the second one, so if you are extending it passes through focus. Second one, if you are taking like this. So optic center F1, 2F1, F2, 2F2. So if the light ray is passing through focus like this, so it passes through like this. After refraction passes parallel to the principal axis. So on the third one, so I am going to the third one. So here is the third one. So optic center here F1, 2F1, F2, 2F2, F2, 2F2. Okay, if the light ray is passing through optic center, no deviation takes place. So it passes like this only. So you can check once convex lens and concave lens. Practice twice. Okay, so we'll complete until this one. We'll see in the next class. So image formations I will explain. Image formation. So we'll see in the next class. Thank you so much. Thank you. From Siva sir.